This is a video from Math 120, section 2.6. We're going to talk about the slope of the tangent line. This is a really important concept in calculus. Most of the rest of the semester is about the slope of the tangent line. The limit definition is developed from the slope of the secant line. So let's take a look at some pictures of what that looks like. So if we look at a secant line, and you should recognize this graph, we did this in section 2.1, we can move a point closer and closer, and in this case a plus h could be on either side, so h could be a negative number, but we want to get closer and closer from both sides. So as we get closer and closer, it approaches the tangent line. So when we say it gets closer and closer, that means the limit as h gets smaller and smaller. So the difference between a and a plus h should get very small. So we have a definition that needs to be memorized. So limit as h goes to 0 of f of a plus h minus f of a over h. And I'll write this in a mathematical form. The limit usually has a h goes to 0 underneath, but I want to just show you what this actually looks like. The dash here looks like an apostrophe. F prime of a is equal to the limit as h goes to 0 of basically the difference quotient between these 2 points. So I have a f of a plus h, f of a plus h. There's a second form that we also use. We could look at 2 points where we're looking at x and f of x, a and f of a. So we want the slope between those 2 points. As we get closer and closer, that's as x approaches a, we get to where we have the tangent line. So the secant line is between 2 points. The tangent line would be the slope. It would be just where it touches, just right there where it touches at a. So the tangent line at a, rather the slope of the tangent line, is f prime of a, and it's equal to the limit as x goes to a of the difference quotient, again, between these 2 points. So the slope between these 2 points. As I pull a further away, you see the 2 distinct points. I get closer and closer. That means x is going to a, and I get actually on top of the tangent line there. So the derivative, the slope of the tangent line, we're going to be able to find the slope of a tangent line at any place where the function is continuous, except for a couple of new places that we need to look at, and those are corners and cusp. So I look at a corner, that's like an absolute value function, and if I get closer and closer to a here, notice that as soon as I got past a, it flipped. So the secant line has a slope that's positive, and then once I get past a, it flips. So the tangent line could be this way if I was looking tangent to a from this direction, or it could be from the other direction. So if I just bump a about a little, the tangent line will flip. So as I'm approaching a from each side, the slope of the tangent line is positive from one direction and it's negative from the other. So the slope will not exist there at a, at the vertex of the absolute value graph. Another place that we'd have trouble is what's called a cusp. So if you're coming in vertically like this, right now, if I drag x over to a, so as x is going to a, it was a negative slope coming in, it was suddenly flipped and becomes a positive slope. So I actually have a perpendicular tangent line here. So that's x is equal to a would be my tangent line. So I could find the equation of a tangent line, but the slope is undefined there. The derivative will not exist. So first I want to remind you that the equation of the line, the one that's going to be important to us, is this point slope form. Y minus y1 is equal to m times x minus x1. The derivative is the slope of the tangent line to the curve. So it's important that we know the equation of the line, because we're going to put m is the derivative for any of the tangent lines that we want. There are two limit definitions. Here they are formally written. F prime of a, and we say f prime of a equals the limit as h goes to 0 of this difference quotient. This is the slope of the secant. This again is the slope of the secant. F prime of a is the limit as x goes to a of f of x minus f of a over x minus a. That's just the slope. Note that there must be a point at a f of a in order for the limit to exist, but we just saw that there were two places, corners and cusp, where this limit is not going to exist. So heavy oscillation, jumps, vertical asymptotes, and holes were the problems with continuity, and there's still problems for derivative, and we pick up two more, cusp or corners. So looking at WebAssign 2.6 section, the first example is to find an equation of the tangent line to the parabola y equals 2x squared at the point 4, 32. I'm going to work this out on paper so that you can see what should go in these blocks. There's some factoring that's going to go on. We're going to have to put some values into formulas, and then they're going to want to factor out a 2. So each of the boxes has to be filled in with exactly what they're expecting. But I'll show you what I would expect for the test. You will have to do this procedure on the test. So we have f of x is 2x squared, 432. So I want the equation of the tangent line, y minus y1 is equal to m times x minus x1. And I also want the slope, which is, I need the slope here. I already have the point, so far I have y minus 32 equals, I don't know what the slope is yet, x minus 4. Now I know we could put this in our calculator and do dy dx and get that slope. But if you do that, that's worth a point. So if the problem's worth 15, you only get a point for that. So make sure that you're not skipping steps here. So the slope is equal to f prime of a, which is the limit as x goes to a of f of x minus f of a over x minus a. So we're looking for that slope right there. So for our particular problem, this is the point a, f of a. That's what the notation means. F of a is the y. That's our y value when x is 4. So we want f prime of 4 is equal to the limit as x goes to 4 of f of x, which is 2x squared, minus f of a, we already know, is 32. You can put it in there and see that it's true. 4 squared is 16 times 2 is 32. Over x minus 4. So I'll factor the limit as x goes to 4 of 2 times x squared minus 16 over x minus 4, which is equal to the limit as x goes to 4 of 2 times x minus 4 times x plus 4 over x minus 4. And I love this part. Things go away. Now I can put the limit in. Note that you have to write the limit until you actually put it in. If you leave these off, I take a point off every time. So be careful that you're not leaving those off. There are no shortcuts here. And for those of you who know what this derivative is because you've had some calculus before, if you take that step and do this, that's nice. That'll give you a hint as to what you need to do. But if you leave off the steps that I'm asking for here, you're not doing what's required for this course on the college level. So putting 4 in, I got 2 times 4 plus 4. 4 plus 4 is 8 times 2 gives me 16. So the slope is 16. So that means that I can put this 16 right there. Now you would be done for me if that was what was required. So let's go back to what WebAssign has and take a look. They say y minus, and then they actually solve for it. So you'll have to distribute it out. So we'll go ahead and solve for y here. This is not required for me usually. So this will be y minus 32 is equal to 16x minus 16 times 4, I think is 64. So y is equal to 16x minus 32. And that should be the answer. So we go back to WebAssign, and we've done most of the work that was in there. So you'll just go straight down the page, put in what we had, and be able to, well, you may have a different number. So you may have different numbers for your exercise. Put in what we have, and you have exactly what you need for the assignment. I'm going to skip down to number 8 and work through that problem. So it says considering the curve, and we want to find the slope of the tangent line. So here I'm going to use Pascal's triangle to expand and then actually find the slope. And this is where x equals a. So they're not telling me a point to put in. We'll do several more with points to put in class tomorrow, but I'm going to work this one by hand. I'll work this one with both of the equations, but we'll start with the one that we just were working with. So we have f prime of a is equal to the limit as x goes to a. I recommend you write it a few times because the more you write it, the more likely you're going to remember it, all over x minus a. So here I do want the derivative of a, the slope width at a. So we're going to leave that in. So this is equal to the limit as x goes to a of f of x, which is just this, 8 plus 4x squared minus 2x cubed minus, I'm going to put parentheses for emphasis, and this will be 8 plus 4x squared, or a squared minus 2a cubed all over x minus a. Now, for this formula, I'm going to have to do some factoring, and for the other formula with the h, I have to do some expanding with Pascal's. So right now we're just going to do some factoring. So what you'll do on the top, you'll get rid of the parentheses here. So I have 8 minus 8, that's going to go away. But I notice that I have 4x squared minus 4a squared minus 2x cubed minus 2a cubed all over x minus a. So that's what I have. If I get rid of the parentheses, I end up with everything drop. This becomes a minus, that becomes a plus, and then I factor out the negative to keep the order the same. Now I want to factor both of these. So the limit as x goes to a, 4 times x squared minus a squared minus, I'm going to factor out the 2 here, 2 times x cubed minus a cubed. And these are both factor formulas that we're supposed to know. So if you're kind of shaky about your factor formulas, make sure you pick those back up because you're going to need them for this next test. So the limit as x goes to a, 4 times x minus a times x plus a minus 2 times x minus a times x squared plus ax plus a squared all over x minus a. Now this limit definition you're going to use on the next test, but you won't have to know it for the final exam. So you need to know it really well for the next test, get all the points you can there, but I won't require you to use it for the final exam. Now if you understand how you reduce things in a rational expression like this, if each of the terms, and I really have 3 terms here, 2 on the top and 1 on the bottom, if each of them contain a particular factor, and this one, the x minus a, shows up in all 3 of these, that means that I can take it out of all of them. I can't just take it out of 2 of them. So if there was one missing here, I wouldn't be able to factor this at all. But basically I can do a GCF, pull this out front, write everything down, but there's a shortcut, and that is to notice that it's in all 3 and cancel it out of all of them. So now we have the limit as x goes to a of 4 times x minus a minus 2 times x squared plus ax plus a squared. Now I'm ready to take the limit. Instead of putting in a number, I'm putting in a everywhere there's an x. That's what this says. Everywhere I see an x, I'm going to put an a. So I end up with, oops, I factored the wrong one out here. This one should have been factored here. I just noticed my mistake. Y'all probably caught that when I did it. So this one goes out. This one is kept, so I need a plus here. So change that. So that's x plus a. I think the other one's fine. So now I can put that x in, and I got 4 times a plus a, which is 2a, minus 2 times, I'll get a squared plus a squared plus a squared. That's 3a squared, which gives me 8a minus 6a squared. So this is my slope at a. Slope of tangent line at x equals a. So that result goes right there. Now they want me to find the equation of the tangent line at two separate points here. They're calling it f of x, which is just another y, and g of x, which is just another y. They didn't say to simplify, so I tend to use y minus y1 is equal to m times x minus x1, and I'll move y1 to the other side. So I tend to use this form of the equation because I don't have to solve for b. So this tells me exactly where I'm putting things. I can go ahead and do almost my entire equation here. So here y is equal to, I don't know what the slope is yet, x minus 1 plus 10. And this one is y is equal to, still don't know the slope, x minus 2 plus 8. I don't need you to simplify this. You can if you want to. If it says to, you'll need to. So I want to find the slope here, and the slope is 8 times 1, this is my slope for this first line, minus 6 times 1 squared, which is just 8 minus 6, which is 2. So this is the equation for the first line. For the second line, I'm going to do the same thing. This is my slope equation. So I have 8 times 2, that's my slope, minus 6 times 4, which gives me 8 times 2 is 16, minus 24 gives me a negative 8. So negative 8 goes right there. And you can leave it just like that, unless it says to simplify. So we just ran through and found the equation of this tangent line, and we used the limit definition of the derivative, the general form, to find f prime of a, using the x goes to a form of the derivative limit definition. So let's redo this problem. Y equals 8 plus 4x squared minus 2x cubed, using the other definition of the derivative. So what f prime of a is equal to the limit as h goes to 0 of f of a plus h minus f of a over h. So I'm going to do this for a few days here. So this is still f prime of a because they didn't give me a point, so I'll just keep writing. Limit as h goes to 0. Everywhere I see an x here, I'm going to put an a plus h. So I have 8 plus 4 a plus h minus 2 a plus h. This should be a squared, I left off, cubed, minus, now I put this in brackets or parentheses to emphasize that this is the first part. I finished that first part, minus, I need the parentheses or brackets here. So this will be 8 plus 4a squared minus 2a cubed. This says f of a, that means go back to my f of x equation, and that's what y is. Everywhere I see an x, I'm going to put an a. So that's what I have there. I'll put a bracket there. All over h. So some things are going to go away. I'm going to factor out an h, and I'll reduce it. I think we did this on the last test. So this is the limit as h goes to 0 of 8 plus 4 times a squared plus 2ah plus h squared, using Pascal's, 1 to 1, right? Minus 2 times a cubed plus 3a squared h plus 3ah squared plus h cubed minus, and I'm just going to distribute this, 8 minus 4a squared plus 2a cubed all over h. Now at this point, I could see what's going to go out here. I've got a 4a squared. See, it shows up right there? So if I strike out the a squared part and distribute to the rest, this part goes away. The 8 goes away already, 8 minus 8. And this is plus 2a cubed, so I'm looking for it, minus 2a cubed. This part goes away. So if you're careful, you can get away with getting rid of a lot of terms before you start simplifying. I have 3 in the first part, in the first set of parentheses, and I have 3 in the second. They should go away. This part, last part here, when you use the h one, always goes away. So now I'm going to factor out an h, and I can see the h factors out. But let's go ahead and distribute it. The limit as h goes to 0 is 8ah plus 4h squared minus 6a squared h minus 6ah squared minus 2h cubed, and all that's gone, all over h. Now, if you understand how to skip steps here, you can skip some, not all of it. I need to see this part, I need to see this part. But then in here, if you realize that you can factor out an h and just write down the result, that'd be fine. So here I can factor out an h. I get 8a plus 4h minus 6a squared minus 6ah minus 2h cubed. So I took out an h out of every one of these terms. 8a, 1h is gone, 1h is gone, 1h is gone, 1h is gone. All divided by h. Now the h goes away and I'm able to take the limit here. So when I put 0 in for h, that means that each one of these is going away. This 4h goes away, the 6ah goes away, and the 2h squared cubed goes away. So I end up with 8a minus 6a squared. And I believe that's what we got in the last one. 8a minus 6a squared. So you have two different forms of the limit definition. I'll require to use them both on the next test. One each for one problem, and then you get to choose one for a third problem. So use this 3 times on the next test. The typical problem in calculus is the bead on the wire problem, or sometimes it's particle moving along a horizontal axis. But you've probably all played with something like this where you've slid beads along a wire and they go back and forth. Well, this problem is saying that we're going to slide a bead on a wire. Kind of looks like this. You start at the positive and go from there. So particle starts moving horizontally and it says to the right. So right is positive. So we're actually interested in the distance it is between this vertical line here and the particle. So over time, this is t in seconds. This actually says we're going to go for a while and gain some distance, and then we're going to hold still, and then we're going to lose some distance and hold still, and then we're going to gain some distance. So you can see it's going to the right when it's gaining distance, it's going to the left if it's losing distance. So you could actually end up with a negative distance from the origin, depending upon how you're thinking about the problem. And sometimes a negative distance is required in mathematical terms. On the last test, we had the instantaneous velocity. You could go to your calculator and figure these out. If it doesn't say to use the limit definition of the derivative to find this, you can go to a calculator. So let's look at this on a calculator. So in y equals, I'm going to put my equation, which is 19x minus 1.86x squared. You know that if we were looking, well, if you've had physics, you know that if we were looking at an equation on Earth, this 1.86 would be 4.9 in meters. So 4.9 would go there instead of 1.86. Let me clear out this second one. We'll just work on this one. So we have 19x minus 1.86x squared. So this is for Mars. So I want to find the velocity, and it says after 2 seconds. So if I just do a zoom 6, I should be able to find the velocity here. So I can't really see it. If I do a zoom 0, it puts it in my window. Zoom 0, so that I can see what I'm looking at. So I have a nice parabola, and this is about the height above the surface. Curve is the height above the surface. So I want after 2 seconds. So that second, calc, dy dx, that's 6. After 2 seconds. So 2 is what I need to put in there. And I have 11.56. It says to find the velocity of the rock when t equals a. Now here you would have to do the derivative formula. So you'd have to put this into one of the limit definitions of the derivative and actually find that formula. When will the rock hit the surface? Round your answer to 1 decimal place. Well, hit the surface means that the distance from the surface is 0. So this means when the rock hits the surface that you're going to set h equal to 0. So I really want to find the 0 here. So let's look at that. I can see that it's not on my graph here, so I need to increase my window. So I'll increase my window to maybe 20. Doesn't matter too much. So now I can see where the intersection here is with the x-axis. Rock hits the surface means that the height from the surface is 0. So it started on the surface, it was thrown up, and it went really fast for a while, it slowed down, it stopped at the top, it sped back up, and it came back to the ground. So second calc, rock hits the surface at the 0. So I want a left bound, I'm going to put it a little bit, well, it looks like I can put it at maybe 9. So that's before, and maybe 15 or 12. So it's asking for a right bound, that's 12. Now I can see my 0 is in between these two, so I'll just hit enter for my guess, and it gives me my 0 is 10.215. It asks you to round to 1 decimal place. I'll expect 3 decimal places for everything unless I say otherwise. And usually I don't say otherwise. The last part is asking me with what velocity will the rock hit the surface. Well, I could go back to my velocity formula once I have that with the a in it and put the time that I just got into that velocity formula. But it's a little bit easier than that because the theory is that if a rock is thrown up with a velocity, it's going to land again at that same velocity, only it's negative because it's coming down. So thinking about that bead on the wire, it's coming back down, it's losing distance, so we'd have a negative 19 meters per second squared. 19 meters per second, rather. I'll also expect you to know the units when you're doing problems like this. The next one gives me everything I need in order to put my equation into a line. So here, I know I want y minus y1, they say is negative 5. There's my y1, negative 5, so that's actually plus 5, is equal to, notice there's not a y equals here, the slope is 3 times x minus, and the x is 4. So you can do more work if you want to, but it's not required here. This is a perfectly acceptable answer. In the next question it says find f prime of 1, so you use the limit definition of the derivative, or you could use your calculator, but I recommend highly that you practice this and use it to find the equation of the tangent line. I will ask you one exactly like this on the test that says use the limit definition, but you also should be able to do it on your calculator and check your work. So if you're in a hurry, especially for this homework, then you could do that on your calculator. Number 13, they're asking you to find g prime of a first. So we've done a couple of problems like this. You want to do this by hand using one of the limit definitions. I recommend you practice them both. And I'll work here at number 14 because we have a new trick. We're going to have to do an LCD on number 14. So let's practice this. So I'll do this using both definitions. So first let's do the x goes to a definition. F prime of a equals the limit as x goes to a, and this is f of x minus f of a over x minus a, which is the limit as x goes to a of 2x plus 12 over x plus 9 minus 2a plus 12 over a plus 9 all over x minus a. So now I need an LCD. So here's our other trick. LCD. This doesn't factor. There's nothing to factor here at all. So here I'm going to need an x plus 9, and over here I'm going to need an a plus 9. So the limit as x goes to a, I'm multiplying. You could think of the top and the bottom by the LCD. X plus 9 times a plus 9, x plus 9 times a plus 9. So if I do the top and the bottom with the LCD for both of the denominators here, which is just multiplying together, Then on the bottom, I'm going to end up with x minus a times x plus 9 in the denominator, a plus 9. And then when I multiply these two together, the first one's going to cancel, so I'll be left with 2x plus 12 times a plus 9. But it only cancels for that one term there. It's back for the second one, minus the a plus 9 will cancel here, so I have 2a plus 12 times x plus 9. So now I have to fold these out. The limit as x goes to a, and I have 2ax plus 2 times 9 is 18x plus, that's the inner, the outer is 12a, FOIL, remember, plus 9 times 12 is, I believe that's 108, minus, I need parentheses here, so we end up with 2ax plus 18a plus 12x plus 12 times 9 is 108. All over the denominator, x minus a times x plus 9 times a plus 9. Now these problems are long, but they're not difficult. Any particular one is not difficult. So what goes away here? I've got 2ax, that's going to go over this one. I've got 18a, it does not go away. At 12x, then the 108 goes away. So I'm left with the limit as x goes to a. And if I rearrange these, I'm left with 18 times x minus a, 18x minus 18a, plus 12 times a minus x, all over x minus a times x plus 9 times a plus 9. Now I notice this looks almost like x minus a right here, so it looks like they almost all three of the terms have x minus a, but it's not true because it's a minus x. So when I reduce this down, I really can get rid of all three of these. This would go to 1, this would go to the 1, but this one goes to negative 1. Just a small little detail. That one goes to negative 1. If you have a highlighter handy, you might highlight that so that you can see it a little better. Now, really here, I could go ahead and put the x goes to a. Everywhere I see an x, I'm going to put an a now because I don't have the x minus a term in the denominator anymore, so things will work here. But let's actually finish this out. So this becomes just 18 times 1, which is 18, plus 12 times the negative 1 is minus 12, all over x plus 9 times a plus 9. Now be really careful when you put this as, because this says everything that is an x is going to turn into an a. So my slope now, putting the a in for x, I've got 18 minus 12, which is 6, over a plus 9 squared. I'm going to work this with the second limit definition of the derivative, which is f prime of a is equal to the limit as h goes to 0 of f of a plus h minus f of a all over h. This is just a slope. y2 minus y1 over x2 minus x1. And you can see that the a's will cancel out. So we don't really have anything but an h there. You want to memorize this. Now on the test, like I said, you're going to have 3 problems that you're going to have to work. One, I'll tell you for sure which one. There'll be actually 2. I'll tell you one for each one of the limit definitions, and then you can pick one for the third one. So you might already have a favorite. So this is the limit as h goes to 0 of f of a plus h, which means I'm going to put in 2a plus h plus 12 over a plus h plus 9 minus f of a, which is 2a plus 12 over a plus 9 all over h. Now I know when I get done here, I'm going to factor out an h and that will be my answer. But here I need an LCD again so I can see that these two don't share anything. I mean, it looks like they do, but they're not factors they're sharing. if I put numbers in here, there's no way I'm going to get the same numbers over here. So these are not the same. They're not factors of each other. So I need an a plus h plus 9 times an a plus 9. So this is equal to the limit as h goes to 0 of 2a plus 2h plus 12. When I multiply, oh, I need it on the bottom too. Forgot that. Sorry about that. So here I'm multiplying by the number 1. I'm changing this so that it's nicer. It doesn't look much nicer, but on the bottom I already know I have a plus h plus 9. This is in the denominator. And in the numerator, I'm just foiling these out when I get done. So I have this one will go away with that. So I'm left with an a plus 9. So this is being distributed to both of those. These two parentheses distributed to both. This one will cancel. We're left with the other. This one will cancel. You're left with the other. Minus 2a plus 12. I need parentheses here. So be careful that you're putting in parentheses where you need them. Plus h plus a plus h plus 9. Now it's an exercise in can you distribute these things correctly? And we'll see if I can. Sometimes I'm not really good at this. But I'm going to take the first one and distribute it through. 2a squared plus 2ah plus 12a plus the second one, 18a plus 18h plus 12 times 9 is 108. Not too surprising, I got 108 there. Minus, I'm going to put parentheses. I'll put parentheses here for emphasis. Don't need them. I just want to make sure that I'm understanding this is my first part. It keeps me better organized. So here I'm going to distribute the a. So I have minus 2a squared plus 12a. Distribute the h plus 2ah plus 12h. And I've run out of room. So what am I going to do? You might do this on the test too. I don't like doing it on videos, but I wanted to show you what it looked like. So this is a teachable moment. So 12h, and then down here I'm going to have 9 times 2 is 18a plus 108. And then on the bottom I have h times a plus h plus 9 times a plus 9. So I know my 108s are going away. So these definitely went away. And if I'm really careful, I'll get rid of some other stuff. So this went away. 2a squared is going to go away. That should be a positive 2a squared there. I missed a sign. 2a squared. And I think that's all that goes away. Now we have a 2ah here. So that's going away. Huh. So we have more going away. 2ah, 2ah. We have a 12a. That goes away. That goes away. We have a 16a, 18a. That goes away. That goes away. Huh, so just about everything went away. So we're left with 18h minus 12h, which I think gives me 6h. So this is the limit as h goes to 0 of 6h all over h times a plus h plus 9 times a plus 9. Those h's go away. And now, because h is going to 0, that h is going to 0. So we end up with a plus 9 squared. So we have 6 over a plus 9 squared. Now, was that what we got for the first time? And it is. So I'm feeling pretty good about having gotten the same result. That's probably my derivative, unless I made a really good mistake on each one of them. There are a few of the problems here that ask you to figure out what f and a will be for these particular functions. So this looks like the a plus h right there. So I'm thinking my a is probably pi, a plus h. And I know if I put in cosine of pi, I do get a -1, so I get a -1 there. So I'm feeling pretty good about it. You're going to match it up with the limit definition. That looks like my a plus h. So I'm thinking that my a is pi. So these shouldn't be too bad unless you overthink them. So don't do that. Down here, the velocity is just the derivative. So it's the slope of the tangent line. It's the derivative, instantaneous velocity. We've looked at that several times. The speed is the absolute value of the velocity.